Well, good afternoon and welcome everyone. And thank you so much for joining us this afternoon for our very first bite-sized corrosion conversation of 2023. For those of you who don't know me, my name is Vanessa Sealy-Fisher, and it is indeed a great pleasure to welcome you this afternoon. As with all our bite-sized corrosion conversations, we really hope that this afternoon will serve you some bite-sized nuggets of information related to corrosion that will make your own corrosion experience perhaps a little easier to digest. Over the festive season, I had a discussion with some of my engineering friends, and our conversation moved towards some of the challenges that they're experiencing when it comes to coating aspects of structures that they design. And so we thought that it might be really beneficial to discuss some of the key areas where problems can arise during the coating aspects of a project. Not that this is going to make you into an expert, but hopefully we'll help expose some of the pitfalls and help you to avoid them in the future. Now, I'm not going to do this on my own, and I'm delighted to welcome Gert Conradie to the microphone today. Many of you know Gert, but for those who don't, Gert has many years of experience in the coating industry. He has been a coating developer and a formulator in the polyurethane industry. He's a coating inspector, and he's also a NACE or AMP approved coating instructor. So he's well qualified, and a very warm welcome to you, Gert.
Thank you, Vanessa, and thank you for everybody that took the time to listen to our discussion today.
So Gert, there's a great challenge that engineers face when they are designing and constructing their steel structure, either above ground or buried, like a pipeline, is that they will need some kind of corrosion protection. And often it appears to be a bit of a neglected area. Maybe we could point out some of the pitfalls that they might encounter along the way. And if we do that over the next few sessions, I thought today we could start, if I could say at the beginning, maybe with some of the paperwork.
That's quite right. Yes, you see, at the outset of any project, typically what the owners of the structure would do is they'll put together a list of requirements that is needed for the successful lining or coating of whatever the structure is. And you know, the controlling documents typically that gets used, you can split it into two separate areas. You could say that you get documents from an external source that you need to gather, and then you've got the documents from an internal source, which is typically like your specifications and your QCPs. Your externals being standards, and then maybe even regulations that is required.
Let's start with looking at standards, data sheets, the kind of external origin things. And I guess the obvious question is, how do we know how we choose the right standard?
That is a very valid question. But I think it's a good place to break it up, because if we start looking at the external sources first, there are so many standards that are out there that are available to use, but they don't get used successfully. And I think that's where a lot of the pitfalls fall. And typically in South Africa, the most common one that gets used is the 12944 standard. And this deals with the corrosion protection of steel structures by means of putting on a protective coating or putting on a lining for that matter. As a matter of interest, the difference between a coating and a lining, well, the one is external, being a coating, and the other one is a lining, being an internal. That would be an external controlling document that will get used by the process engineers. And a lot of what the engineers and the designers will do is they'll refer to this documentation to see what is the environment that the structure will be placed into, and based on what the standard actually guides you according to, you can then decide what type of coating system to put on. And I think it's a good thing, because unfortunately there are a lot of field chemists out there, if we can put it that way, that have the idea of putting out thicker is better, and that's typically not the best way to go.
I think, Gert, if you can take us through perhaps some of the gremlins associated with using ISO 12944.
The biggest problem that is out there is the fact that a lot of people, when they go through the 12944 standard, is that they take it up too literally. So your classifications that you have in your 12944 standard will go into different parts. And unfortunately, a lot of the engineering companies normally only refer to 2 of the parts of the entire document that consists of 9 different parts. Part 1 is actually the general introduction, and thereby telling you what the 12944 standard is and how you can apply it. Part 2 then classifies your different type of environments. And this is where they look at. And when they look at the 12944 Part 2, it classifies it between a C1 to a C5 classification. C1 being the corrosive level or the category that is the lowest, and then C5 that of being the highest. Now, when they look at a structure, and when I say they take it up to literally, is the fact that when something is built rurally or built inland, they say, oh, well, C1 is quite fine. We don't need a higher classification. Let's spec everything according to the C1 standard. But what they don't realize is if they've got a structure or if they've got an actual buried pipeline, it falls in the same category as a C5 classification, which is a highly corrosive environment because it's a buried structure. So just quickly going through what those 9 different sections is, and I would like to mention them because just looking at their actual titles will help a lot of the engineering companies and designers use the right part and spec the right part of the actual specification. So as I've mentioned, part 1 is the general introduction, just saying what the standard is. Part 2 is the classification of the environments, C1 to C5. And then obviously part 3 is the design considerations. And here again, a lot of the designers don't actually look at that portion and they overlook certain areas of it. The type 4 talks about the type of surface preparation that one can have. Type 5 talks about the protective paint systems. Number 6 talks about performance testing in laboratories. Number 7, the execution of supervision. Part 8 is the development of the actual specification. And then obviously part 9 is the protective paint system and laboratory performance testing methods. As I've mentioned, most only look at part 2 and they look at part 5. They look at the environment, and once they've classified the environment, they say, okay, this is the paint system that we need. Now comes the challenge. When they look at this, what version are they looking at? You see, from 1998 up to 2018, the 12944 standard has undergone so many different revisions that they still might be using an old method for specifying or wanting to make part of their specification in order to say, according to 12944, we want table 5 to be used according to the standard. But that table has now changed. For instance, some of the water industries and other industries do not want to make use of solvent-based systems anymore, but actually want to go over to a water-based system, especially in the waterworks industry. And in what also has changed, when you look at the 2018 version, they have actually now included harsher conditions. So not only do you have classification of a C1 to a C5, but they've included things like the CX standard and IM standards, which is the immersed standards for offshore platforms and vessels that go offshore. Also, what has changed is that the 12944 standard has now incorporated what's called cyclic aging testing, which is basically taking various corrosive levels and saying if it is exposed to that environment over so many time, cycling it through different stages of the year with seasonal changes, how does that affect my coating system? And when they discovered that, they also then included a maximum level or a highest or thickest dry film thickness for individual coats, not just for your primer, but right through the system. And this is to make sure that they improve the performance and also the longevity of the actual paint system that gets applied onto the structure.
With ISO 12944 having undergone significant changes, I'm sure you will agree it would be really worthwhile for every engineer who is specifying coatings in compliance with that to ensure they have the latest version of the full standard so that they can verify what they are referencing is from the latest. The current one is the 2018 version, as opposed to some old archaic version that has been dug out of a dusty drawer somewhere.
Most definitely. Especially if they're designing new structures, which is what we're talking about now. Unfortunately, when these new structures are being built, they still use an old 12944 standard, maybe the 1998 version or the 2005 version or the 2010 version and so forth, which doesn't have the protection criteria as the latest version has. But what is important, Vanessa, is that if one is now inspecting some of these structures and one needs to go and actually see whether the performance has taken place, one needs to inspect according to the standard that was used at that time. So if it was a structure that was built in 2010 or 2015, it's pointless to use a maintenance type coating that now applies to the latest standard, because it might not be applicable for the older standard that was used.
Certainly. So just as a pitfall worth making a note of for our engineering friends is that you need to consider, for a new structure, you use the latest standard. For the older structures, you can use what was in place at the time. And I just want to put a quick caution out there. I'm sure many of us have been exposed to this availability of OpenAI or ChatGPT, just to be aware that not everything you receive through these portals is correct. I did a quick searching on the weekend for this presentation using OpenAI, looking for standards. Every single one of the 7 standards it recommended have been withdrawn. And in fact, 4 of them are now related to hacksaw blades and not coating. So I think it's very worthwhile that the engineers take note of the fact that the standard that they're referring to is still in existence. And you can do that by going to the ISO site or in South Africa, to the SANS site to search for it within there.
Most definitely. And I think another pitfall that we need to watch out for, and let's call it a gremlin as per our discussion, is the fact that sometimes a lot of people don't look at the entire document in its totality, if I can put it that way. They use certain extracts out of it, and then they interpret it in the way that they understand it without looking at a different section. Like, for instance, one area might only talk about surface preparation, but then it will say refer to part 2. When you go to part 2, that will refer to a different standard that you now need to also acquire in order to make sure that you're actually coating or lining the actual vessel or structure in accordance with what you have spec'd using the standard in the 12944. And there are so many different standards out there. It could mention a standard that's an American standard, an ISO standard, Canadian standards, ASTM test methods, and various others that it can refer to.
Yeah, just moving on a little bit. Obviously, one of the things that engineers often do is they consider what product they could or would like to have applied to their structure, and they may even specify that. And one of the aspects of that I think is often neglected by engineers who are designing corrosion protection systems is that they don't consider the data sheets of the products that they anticipate using. And I think maybe we can just move our conversation on a little bit to looking at the data sheets, because that's also, in a sense, a document of external origin. And I think there are some serious gremlins or pitfalls that we can consider there.
Most definitely. And there are so many different products out there and so many different product data sheets. One has got to be very careful that you also, again, using the latest version that is available. Paint formulations have changed. And you referring to the 12944 standard, it might say that you need to apply a coating to a certain thickness. But the latest version of the product data sheet might say that you don't have to put it on that thick anymore because they've changed the pigment structure. Therefore, you can put it on thinner. So you can see where discrepancies come in that needs to be clarified before the job actually starts. Because obviously, the applicator that's doing the work is going to want to do it the cheapest and the quickest way instead of trying to stick to a different way. So yeah, I think it's a good idea if we maybe just go through some of the aspects of a typical data sheet.
Certainly. As I pull this up, just 2 comments. The first one is that very often there are 2 data sheets available. One is a safety data sheet and the other one is a technical data sheet. And obviously this discussion is particularly pertaining to the technical data sheet. And the other thing, just as we go through it, this is not the latest version, just this is an extract of a technical data sheet.
So looking at the product description is very important to say, is it compatible to use? A lot of the coating inspectors are taught to use that volume solids and incorporate the actual thinning into that volume solids. So even though in the next line where it says film thickness per coat and it gives you a wet film thickness range there, that does not include the thinning of the product. So if you've thinned the product 10% or 15%, it's going to cut your volume solids but increase your wet film thickness. which means that even though your applicator thinks he's applying it at the correct thickness using a wet form thickness gauge, he's not, and he's actually putting it on thinner because it will dry to the original dry form thickness that it's supposed to, but he measured it incorrectly, therefore it's going to be under film thickness.
Okay, that's also something that I didn't think of, and definitely something to look out for. Yeah. One of the other sections that they do include in many technical data sheets is surface preparation. Does this override the surface preparation that's been specified by the standard?
Most definitely not, and it shouldn't, because the ruling document that one will always use is your specification. But what is important to note is that, again, it comes down to compatibility. Can I use it for what is specified? 12944 could be used for a coating system to be put on carbon steel or to be put on galvanized steel or aluminium. And at the same time, it can also get used for concrete. But there are other standards that you now need to pull out if concrete is being used or aluminium is used or galvanized is used when it comes to the surface preparation. And that's to what this section in your product data sheet is referring. It says be careful that if you are using this, don't just stick to a normal carbon steel surface preparation guide. You need to conform to something else. As you can see on this little preparation that they've got here. Minimum being a ST2, which is a hand and power tool method of cleaning. And if it does get blasted, SA2.5 on carbon steel, but other standards then apply depending on what your surface is.
So this is not just a quick fix. It really needs careful thought when you're interpreting this data.
Most definitely.
Let's have a look at some application challenges.
And I was just going to say, thank you for bringing that up. And I think that this is the page that the applicator typically goes to first. He just wants to know, how do I put it on? How do I mix it? What is my temperatures? And off I go without looking at the previous ones. So the previous ones one can use as your guide to say, okay, if I'm going to apply it by means of spray, what type of spray system can I use? If I'm going to use a brush, what type of brush am I going to use? Or roller? And some of these coating systems, when you read through the application, they are so specific with regards to how you put it onto the surface that you have to use that specialized equipment. Especially when it comes to hot cured polyurethane systems or polyurea systems, you can't just use a normal brush or an airless spray to put that on. And that's what this guide is. It guides you through that. And as you can see there again, it says the method it gets used. It tells you what the ratio is. Sometimes they'll break it down by volume and by mass, which is also very important. If you see somebody on site busy cutting different type of containers because they want to partially mix only some because they've only got a few square meters left, how are they mixing it? Are they using a volume calculation or are they using a weighed calculation using a scale? And there are differences in the two because of the actual densities of the products that differ. And I think on this application, the most important thing that we see there is in the middle when it says, what is the thinner that gets used? What's the cleaning solvent? Contractors tend to want to use the cheapest that's available. They don't like to use the original manufacturers because either it's more expensive or they've just seen that it works better if they buy the cheap stuff from the local store. And unfortunately, this is where the guys in the white coats that work in the labs have formulated that paint to cure over a certain period of time for that thickness of the coating using that specific formulation of thinners or solvent. And if they use the wrong one, they're going to run into troubles.
Great. And then, of course, the thing that often is a driving force is how quickly is this jolly thing going to cure, because we are under great time pressure. The last thing to happen is to put the coating on and we're behind on the project.
Exactly. And I think those temperatures not just apply to while applying the actual paint, but while mixing and thinning it as well. If the temperatures are elevated, and typically the contractors bring their paint on the back of a bakkie, so it's hot and they store it next to the vessel that they're going to paint in the sun. They don't all do that. I'm just mentioning the GREMLINS that's out there, if I can put it that way. And they get hot. And now if you mix it, your pot life is severely compromised. And your induction time, which is the time that you need to leave it in a container before applying it after mixing, is also compromised. And there's your data sheet. It gives you the guide. It says if it's at -5 or 0 or 5 or 10 or 20 or 40, these are the times that you need to adhere to, otherwise you're going to run into trouble. And chucking more thinners in is not the answer. If it's a two-component system, it's not going to cure.
And I think that's also something just to remind everyone, is that these are highly complex chemical components. And so just thinning it with a bit of extra water or a bit of extra thinner doesn't make these problems go away. In fact, it can create additional ones or exacerbate them. And that's something that must also be taken into consideration. The data sheets, here you can see, Pat mentioned the pot life and the induction time. So at room temperature, you've only got 2 hours within which you can apply the paint. And even at the end of that 2-hour period, the coating may seem like it's still liquid, but the curing process is such that it actually won't cure correctly.
Correct. And that's exactly what the problem is. And like I say, what normally the answer to that question is, well, we'll just put a bit of extra thinners in. But as you've quite rightly mentioned, this is a chemical formulation. The cross-linking internally has already occurred. The thermal expansion of some of those chemicals inside have taken place. So you just disrupt those links if you add anything or if you extend the pot life.